Alright, this slide you guys are going to want to hit pause and write some of this stuff down. I took what's in your book and kind of arranged it a little differently. If you have a number in front of your absolute value, so look at this function here, y equals a times absolute value of x. If this a value is bigger than 1, so if it's a number, a whole number, or an integer, your graph is a stretch, a vertical stretch. It's almost like someone grabs the y-axis and pulls. That's where this comes in. The graph is narrower than the parent function when you have a number, so a whole number here. If you have a fraction and it's less than 1, your graph is vertically shrunk or compressed. So again, this one is where someone grabs the y-axis and smushes it together. So this is like, think a fraction. It's just got to be less. This can still be, this doesn't have to just be a whole number. It just has to be a bigger than 1. I just want to clarify because some people think of it as the negative. The negative doesn't matter if it's stretched or pulled like that, stretched or shrunk. The negative gives it a reflection. If that a value is a negative 1, then you just have a parent function that's reflected in the x-axis. If a is still negative, but it's not negative 1, then you have a stretch or a shrink combined with a reflection. So it's kind of just talking about the differences. If this is confusing, remember you can use that XY table to help. But go ahead and write this down, get this in your notes, and we'll do an example. Okay, so we have two different examples of stretches and shrinks. So we'll graph the first one here. This is y equals 1/2 absolute value of x. So we want to graph that function and compare it to the parent function. But what I'm actually going to do is graph the parent function first and then the new one, because then we can kind of see how it changes and at least get our points on there. So parent function just involves me putting some values in for x. So I'm going to put 1 in there. Absolute value of 1 is just 1. Absolute value of 2 is 2, and so on and so forth. Now, because this one is the parent function, I know the vertex is at the origin, and I can just reflect over those points. But if I put in a negative 1 for x, absolute value of negative 1 is still 1, etc., etc. So I'm going to fill in my v. Okay, now let's look at this new function. This new function wants me to take all of my parent values and multiply them by 1/2, which remember is the same as dividing by 2. So I'm taking my function, let's say I put a 1 in there for x. They want me to go absolute value of 1 times 1/2, which is just 1/2. So that's my first point. 1, 1/2. So we got to kind of estimate. We'll go halfway between 1 or 0 and 1 on the y-axis. Then it's still going to start at 0, 0, because if I put a 0 there in for x, absolute value of 0 is 0 times 1/2. You still get 0. Let's put a 2 in there for x. Absolute value of 2 is going to be 2. 2 times 1/2 is the same as 2 divided by 2, which is just 1. So 2, 1. Now let's put in negative 2. Negative 2 goes in there for x. Absolute value of negative 2 is 2. Again, 2 times 1/2 is going to be 1. So we'll go to negative 2, 1. So you can kind of see what's going on here. My new function, I look and I say, oh, look at that. That a value is less than 1. Must be a fraction. So that means I have a vertical shrink. Someone took my y-axis and smushed it together. So this compares by being a shrink on the y-axis. I want you guys to give this graph a try. You're going to graph the second one. It says y equals -3 absolute value of x. It looks like that a value is a whole number, but it's a negative. So it might combine a reflection too.